let's find the solution to this initial value problem. So looking at the differential equation, it's a first order separable differential equation. So let's start by solving that. So what I'll start by doing is by isolating my dy dx term by moving the negative 3y to the other side, making it positive. You can factor out the 3 or do it however way you'd like, but me personally, I'm just going to take the whole thing and divide it. So I'll have 1 over 6 plus 3y dy on my left hand side, and then on my right hand side I'll just have my dx term there, and I will, now that I'm done with the separation, I can integrate the both sides. So my left hand side, it's going to end up being a log, and because I have a 3 attached to the y, I will have a factor of 1/3 multiplied by that natural log of just whatever is in my denominator, so 6 plus 3y. And then on my right hand side, it's just dx, so then I'll just have an x plus an arbitrary constant c. And now, so that I can isolate y, or solve for y, I'm going to multiply both sides by 3 to get rid of that 1/3. So then I'll have ln 6 plus 3y is equal to 3x plus c. The arbitrary constant c just absorbs that 3. It doesn't really matter. You can go the extra mile and redefine c as a new constant, but we don't need to do that. And now I'm going to take the exponent on both sides to get rid of that log. So I'll have 6 plus 3y on my left-hand side is equal to e to the, actually, more absorption happening. I'll have c times e to the 3x. And the way I got that c multiplied by the e is, I'm going to write that in here so you could see all the steps. It ends up being e to the 3x times e to the power of c, or e to the 3x plus c, which becomes e to the 3x times e to the power of c. And because that's just a constant, I absorbed it into another constant, which just becomes c again. And that's how I ended up with this form. Now I'm going to take 6 to the other side and also divide by 3 all in one step. Or actually, let me not rush. So I'll have 3y, taking 6 to the other side, c e to the power of 3x. It becomes negative 6. And then dividing by 3, I have y is equal to c e to the power of 3x minus 6, all divided by 3. Now that I have my solution, it's not the specific solution because I have my initial value problem that I did not apply yet, and my initial value condition tells me that y is equal to 5 when x is equal to 0. So by plugging that in, I have 5 is equal to c, e to the power of 0 is just 1, minus 6 over 3. Now doing some algebra, multiplying 3 by both sides, I get 15 is equal to c minus 6. So that tells me that c is just equal to 21. Plugging that all back into my solution, I get y is equal to 21 e to the power of 3x. What was that? Minus 6 over 3. And making things cleaner by simplifying, I get that my solution y is equal to 7 e to the 3x minus 2. And that's it.